Nice to see everyone. I'm Luke Marsden. I'm going to talk about how we can all be AI engineers and importantly how we can do that with open source models. I think the discussion that we just had about security risks from sending your data to SaaS providers is really relevant to this idea of using open source models and hosting them yourselves, because then you get like real true control over exactly where your data is going, and you can keep it all like actually inside your firewall. Yeah, just so to kind of introduce myself, I'm the CEO at HelixML. We're building a private GenAI stack that you can run on your own infrastructure. I also have a business called MLOps Consulting, so I consult with companies all over the world on MLOps and more recently lots of stuff around large language models, of course. I also helped create an organization called the MLOps community. So if you're interested in things like MLOps, then check out mlops.community. There's a Slack channel with like 20,000 people on it and loads of good resources. And my friend Dimitrios, who runs that community, does loads and loads of good content. So I recommend it. And just like my brief journey is that I started doing DevOps with a company called Cluster HQ. We did storage for Docker in the early Docker and Kubernetes days. And then my second business was an end-to-end MLOps platform, kind of pre-GenAI. So I've been kind of exploring DevOps, MLOps, and now GenAI. So my point in this talk is that we can all be AI engineers. So everyone in the room is now able to do AI engineering, which is to build applications on top of LLMs, because the tooling is now easy enough that we can all do it. It used to be that you had to be like a PhD in neural networks to do any of this stuff, but in the last couple of years, it's got really easy. And so I'm going to show you how you can do that with some live demos. And my point here is that you can easily prototype an application just like in the browser by pointing and clicking. But actually, who here has a DevOps background? Interested to see, yeah. And that's cool. So I also really want to focus in on like how do you, because it's really easy to prototype one of these chatbots or whatever, but actually making a production-ready version of that application, there's normally a big gap. Like you can prototype it in a day, but it will take 6 to 9 months to productionize. And that's often because of like dealing with all the edge cases and testing that application and setting up a pipeline to deploy it. So I also want to talk a bit about how you can go from that prototype to a production-ready system. But first I'll talk about prototyping. So prototyping involves picking a model, writing a system prompt for it, plugging in knowledge, and plugging in integrations. And so knowledge is where you bring kind of documents or text to the system and give it sort of ground it in truth. And integrations is where you enable that model to make API calls on behalf of the user out to external systems, whether it's like Salesforce or Jira or GitHub or whatever it is that your application is doing. And yeah, so there's that prototyping phase. And then the productionizing it is just like productionizing regular software. So how do you productionize regular software? Well, you write tests and you configure deployment. So that's CI and it's CD. And my argument here is that for GenAI applications, you should do that in exactly the same way that you do with regular software, except writing tests for LLM applications is a bit different, and I'll talk about how it's different. And the actual act of deploying it can be different as well. My argument is that the correct way to do this, to actually manage these applications once you've rolled them out inside the business, is version-controlled YAML files in Git. Like that's how we do DevOps, it's how we do infrastructure as code. That's also how we should do GenAI. So yeah, I'll dive into, and I'll go quite quickly through this bit because I think we touched on some of this introduction stuff already. But the building blocks for GenAI applications are these things that we have here. Models, prompts, knowledge, integrations, tests, and deployment. So models, I mean, what are these LLMs? I think of them as big wiggly shapes because they are big wiggly shapes in a massive multi-dimensional space. But us humans like looking at three-dimensional spaces. So you can think of like the input, what is the capital of France, being turned into a number, like an XY coordinate, and the answer being read off as like what point you get on the graph. And the answer is Paris. And this is basically what's happening inside LLMs, just like it's a much bigger multi-dimensional space, and the amount of data on that that surface has is like gigabytes. But that's what's really happening. Like when you type something into an LLM, you are what happens is that your text gets turned into like a vector, a number, and then a vector comes out of the model and then gets turned back into a sentence, and that's effectively what's happening. Then prompting is just telling the model what to do in natural language. And you can kind of think of this as like programming an LLM just using English. And so, for example, one of the prompts that I was iterating on recently was present the key information in a concise manner. Like this is taking an API response and then summarizing the response of that API back to the user. I had to add perform any actions requested by the user in order to make the LLM also kind of do what the user told it to do rather than just summarizing the response. So it's all about just tweaking the way that you prompt the thing in order to get good results. Knowledge is all about giving the model knowledge it can search across and refer to. And the way that works normally is with a system called RAG, which is a fancy phrase that means retrieval augmented generation, but I prefer just thinking of it as knowledge. The basic idea here is that you take content, you chunk it up into pieces, you put those pieces into a vector database, and then when a query comes along, you also put the query, the user's query, into the same what's called an embedding model, which is what you use to take like sentences and turn them into numbers. So you put that, or vectors, and you put that same vector into the vector database, and you just do a similarity search, which think about like lots of points in a space, and then like you've got another point, and you want to just find the points that are closest to it in that space. That's all that the vector database is doing. And people call it semantic search. But basically the idea is you whack a bunch of data into the database, you turn your prompt into something that allows it to be search for things that are near it in that space, and then you take the top 3 results or whatever, and then you feed the question along with the results into the model. And so you can tell when I wrote this talk, which was July last year, but basically what I did was I fed all of BBC or a bunch of BBC News articles from that day into the vector database, and then I asked like how much did Kamala Harris raise, and the vector database gives you back like 3, well in this case just 1 relevant snippet of text, and then what happens is you take the question along with the snippet of text that's relevant to the question, and you give it to the model. And now the model has a much easier job to do. It doesn't have to like know every fact in the universe. It just has to take the question and the answer to the question and then summarize that into a nicely worded answer. So that's why RAG works, and it gives you much more accurate results if your vector database has relevant stuff in it. So that's that kind of knowledge piece. The next piece is integrations. Hey. Yeah, sure.
What's the minimum amount of data you need?
The minimum amount of data you need to do RAG? I mean, I don't think there is a minimum. I think one of our examples is like, Luke has a red car, Carolis has a blue car. Like, if you've got any facts, then you can put that into a RAG database and it will work, yeah. This is different to training a model, by the way. This is just a technique for taking a model that you can do inference on and kind of constructing prompts for it that have relevant context in them, if that makes sense. Cool. So yeah, the next thing I want to talk about is integrations. So making it so that you can take a model and allow it to make API calls into business systems on behalf of the user. So the way that you can do that is that you can take a prompt and pass it to the model. But actually what happens under the hood is that prompt gets passed through a sequence of other prompts sort of built into the system that does the API calling. So the first one is to classify the user's query. So the classification prompt gets told, oh, you've got these 3 tools available to you. You can either query the product catalog API, you can query the customer API, or you can go and do a Google search. And then based on the user's query, the job of the first prompt is to decide which of those tools, if any, to use. So if the user asks, like, have you got any sourdough in stock? If you're a bakery, then you might go and make an API call to the product catalog API. And whereas if the user is asking what's the capital of France, then the classifier will say, you don't need to make any API calls to answer that question. You already know the answer. But then if the second step is preparing an API request. And so what that does is do people know what I mean when I say like Swagger spec for an API? Yeah. So like a Swagger spec for an API is just a description of that API and the different methods that you can call on it. And so in the prepare step, the LLM is actually given the Swagger spec and given the user's query and then told to construct a valid API call to make to the API. And then the third step is and then the system needs to go and actually make the API call, get the response, and then pass it to step 3, which is summarization. And I'll show you this all working in a minute, so it'll be less mysterious. Right, and then testing. So testing normal software, you have to do, of course, with integration tests, unit tests, which are like code. How do you test systems that answer in natural language? Well, the way to do it, and this is maybe a bit of a funny example, but the way to do it is to define a series of tests which where the expected value is described in natural language, and then what you do, there's a pattern called LLM as a judge. So you basically have a sort of integration style test where maybe you've done like an API integration with your product catalog API. You can then say, when I ask for like this type of bread in my bakery, I expect to get a certain response, and it should be relevant. And so you can describe the expected output in natural language. And then what you do is you get an LLM to grade the result. So you get an LLM to say, given the output from this system and this description of what we wanted the output to be like, does it actually match? And then you basically just get the LLM to give a pass or fail grade. And it turns out LLMs are also quite good at this kind of grading the answers problem. And then, so you can take this kind of version controlled spec, integrate this with like Circle CI or GitHub Actions or Jenkins or whatever, and then every time someone pushes a change to the branch, you can imagine that the system would automatically run all of the tests that are encoded in this model spec, in this application spec, against that application, and then it's just like normal CI now. It's like every time you push a change, you might change one thing and inadvertently break something else, but now your test suite can catch it. So that's this idea of kind of test-driven development or CI/CD for GenAI. And then deployment is all about just running stuff on a server. And like I said, I'm a big advocate for running open source models on your own infrastructure if you can, because it just sidesteps all of these worries about, like, do you trust Sam Altman with your data? Or like now with DeepSeek R1, it's like, do you trust the CCP with your data if you use their SaaS? So it's kind of getting harder to justify that. Run the stuff on your own infrastructure. That can be your own VPC on AWS, or it can be your own GPUs that you've just got in a data center or even in your office. We've little plug for what we're working on. There's a one-line install script to set up our stack on your infrastructure that means you can do everything I'm going to show you on your own machines. And then this deployment piece is about, if you saw kind of what we were doing with testing here, with testing, we're running the tests every time you push code to a branch or a pull request. Deployment is just like if all the tests pass and you just push to your main branch, then deploy the app, deploy it to production and set up this sort of continuous delivery flow. Or if you want to get really fancy, any Kubernetes fans in the house? No. Excellent. We've managed to split the room. That's fine. I'm also not the biggest fan of Kubernetes, although I worked on it for ages. But if you do like Kubernetes and you want to do fancy things with Flux and CRDs, then we've also put together this Kubernetes operator that you can push changes to a Git repo, for example, and then have Flux automatically reconcile changes. So what I'm trying to show in this talk is that this kind of new world of GenAI is not that complicated. Everything I described hopefully was fairly comprehensible, and it's just about like understanding these different pieces of the application or the different pieces of the stack that you're putting together when you're building these applications. Yeah, I wanted to use the remainder of the time to try and do a live demo. Do you mind trying to put that thing on there so I can talk and type at the same time? Thank you. It's a bit short, isn't it? Should we move that? Okay, yeah, that works. I've done this before.
We're good?
Cool. Can you still hear me? Okay, it's working. Right. Please pray to the demo gods. I also wanted to say, if you want to, you can play along. So everything I'm going to show you, you can do yourself at deploy.helix.ml. So at deploy.helix.ml, we give you a free virtual machine if you sign up, and that VM is already running the stack. So basically, we give you a VM that we already ran that command on for you, and we plugged it into Together AI, which is a place you can get LLM inference. So yes, here is deploy.helix.ml. I created this deployment earlier. I can show you. It's easy to make a new one. It will spin up that VM, and we've got like a pool of them running already, so it's like really quick. But what I'll do is I'll go to the one I made earlier because, because I know it works. So what I'm going to show you is making some of these apps some of these different types of apps that we talked about earlier. So the first one I'm going to do is a knowledge app. So what I'm going to do is I'm going to make like a talking brochure. I'm going to call it brochure app. And I'm going to say, try and sell enterprise software, because I don't want to have to sell enterprise software myself. I'd rather have the AI do it for me. And then I'm going to give the AI some knowledge. So I'm going to upload a PDF. And then I'm going to click there to upload a PDF. And then what that's going to do is that thing I described earlier of kind of chunking the contents up into pieces and then running an embedding model to put them all in a vector space, which basically means, like I was describing, you can think of it as like a bunch of different points in a space. And then when you come up with a query, you're putting that into the space as well and finding the points that are near it. So, for example, if I type founders into here, I can do a vector search over the chunks that came out of that PDF. And one of those chunks contains information on the founders of the business. So what I'm then able to do is I'm able to ask, who are the founders? And what that does is it very quickly takes that PDF text, not the whole PDF, but just the bit that's relevant to the query, includes it along with the question, and then answers the question. And I think because I told it to be salesy, it's gone extra enterprise sales on me. But that's what I asked it to do. So that's the first thing you can do. And notice how we uploaded that PDF in just a few seconds. It didn't take very long to build this application. The other thing I want to point out here is every time that we click buttons in the web interface, it's modifying this YAML file behind the scenes. And that's really important because remember, pointing and clicking on web interfaces is not how to do DevOps. We stopped doing that with Jenkins years ago, and I don't want to have to go back to that. So what is really important is that you allow people to play around and prototype these apps quickly, but then you very quickly, when you want to take that anywhere near production, you copy paste the YAML file out of here, you put it in a Git repository, and then you configure CI/CD for it. And then by also adding tests to it, you can then get kind of software and DevOps best practices for these GenAI applications. So that's what I'm trying to convince people is a good idea. So I did the brochure. I wanted to do another one. Another quick example is an exchange rates app. So remember how I said you can integrate these apps with business systems. So I'm going to plug in an open API spec, a Swagger spec, for an exchange rates API. And this is erapi.com. It was just some random open API that I found for querying exchange rates. And then you can also plug in your own Swagger specs for your own internal systems here. And you can say, what is USD GBP? And what you can see is it's going and making an API call on behalf of the user, and it's giving you live, correct information because it's actually gone and made that API call behind the scenes. So that's the second example I wanted to show you. The third thing I want to do really, really quickly, because I know I'm a bit over time, I wanted to show you the testing piece. And then I'm going to leave it to your imagination how you would integrate this with GitHub Actions. But basically, let's start by looking at, let's look at a comedian.yaml. So what I've got here is I've got a comedian. The system prompt is you are funny. And we've also defined some tests. So what we want is we want our comedian to tell us a joke on every single interaction. So we give it an example, hey, and we expect a joke. And we say it must be an actual joke. And remember, we're using an LLM as a judge. And LLMs know what jokes are. And they're able to take a piece of text and evaluate whether it's a joke or not. They don't have a very good sense of humor, but they're able to do that at least. So what I can do here is I can do HelixApply-F, comedian.yaml. If you're familiar with kubectl, that should look quite familiar. And then when I go in here, I can see, I've got this comedian app. So I'm going to launch the comedian app. Good old Bill Hicks, rest in peace. So let's say hey to Bill Hicks. So, okay, fine, but Bill didn't tell me a joke. Let's run the tests. Helix test-f comedian.yaml. So that's going to run the tests and generate a test report. Oh, look, it failed the test. It failed because the response is a casual greeting but does not contain an actual joke. So you can imagine how you can do more complex things like a Jira integration that's got 10 different cases that you want to test and checks that the application can write all the valid JQL that goes in the API call, right? And that's a real example, by the way. We've got this whole sort of Helix Jira thing. In fact, I'll show you that just very quickly. Here are all the different cases that we cared about when we did our Jira integration. We want to be able to say what issues are there, what issues are assigned to me, and so on. And the really important thing about this was that we had to actually teach the LLM how to write JQL, which is the Jira query language. So by giving it these sort of nuggets of wisdom of this is how you talk to the Jira API, we were able to make all of those tests pass. And so we were able to make an app that was actually better. And as we were iterating on that, we were able to ensure the quality of the thing. So anyway, just very quickly, Any ideas on how we can make this comedian always tell jokes?
Feed it more data.
No, we don't need to feed it more data, yeah?
Tell the prompt to tell a joke.
Yeah, tell the prompt to tell a joke, exactly. It's that simple. It's like, always tell a joke on every interaction. Oh, I can't type. So even before we commit this, we can run Helix test and see if it's now passing the tests. It did. Okay, it passed. So well done. We can now also look at that joke. Why did the coffee file a police report? Because it got mugged. Not very good. Okay, so that's all I've got really. I wanted to just very, very quickly here do a shout out. So we're working on this like spec for how you define these apps that are like valid Kubernetes CRDs. That's called AI spec. So if you're interested in that, check it out. And if you'd like to connect with me on LinkedIn, that's my QR code. I'd love to talk to anyone who would like to talk more about this stuff. Thank you very much.